Okay, my friends, this is the last example for 8.2 equations of planes. It's number 17 on page 452 in your textbook, and it's more of a thinking type level question. A really good one for those of you who are planning to take math next year at university, because you definitely need these types of thinking skills once you get there. So the question says determine the value of k such that the points A, you know what? I'm going to pause you a sec, and I'm going to write down those points so I don't waste your time. Be right back. Okay, hi guys, I'm back. I wrote down the points. I didn't want to waste your time because I write really slow with this stylus. Okay, so the question says determine the value of k such that all of those points, A to D, lie on the same plane. All right, so we really need to think about this. There are actually many different ways to do this question, but I believe that I have found a really good efficient way. So I'm going to show you how to do that now. If all of these points are in the same plane, then I should be able to get some direction vectors for the plane using these points. So let me start by doing that. So one direction vector could be AB, which is -4, 1 minus -2, so 3 and -6. Another one could be BC, which is 1, -1, -5. And I'm going to also get one, I'm going to get CD, which is going to have a K in it, but that's all right. It's not going to bother us, and in fact it's going to help us, which you'll see in a couple of minutes. So -2 minus -5, so that's +3. So 0k3 is the vector CD, which is also a direction vector for the plane, even though we don't know what k is yet. All right, so if these are all direction vectors for the plane, then recall that if I cross any of these two vectors, if I take the cross product of any of these two vectors, for example, AB cross BC, then what am I going to get? I'm going to get a vector that's perpendicular to both. If these direction vectors are in the plane, and I get a direction vector that's perpendicular to both vectors, then that vector, let me say that again. If these direction vectors are both in the plane, and I cross them to get a vector that is perpendicular to both, then that vector is perpendicular to the plane, right? Makes sense. So let's call that vector the answer to AB cross BC, E. If E is perpendicular to the plane, which we've just established, then the dot product of E with any other vector that's in the plane should be 0. Well, guess what else is in the plane? Vector CD. Right? So that means that the result of the cross product of AB and BC, which is E, which is perpendicular to CD, which is in the plane, when I do the dot product of those two, the result should be 0 because they're perpendicular. Now, how does that help me? Well, that helps me a lot because the vector that I will get when I do the cross product of AB and BC will be all numbers. I'll know all the components of that vector. And then when I dot it with CD, I'll have only one unknown, k, and I'll have an equation that equals 0, so I'll be able to solve for k. So I hope you sort of understood that, but you're going to see how it works now as I do it. Or hopefully better than sort of understood it. Okay, so let's start with AB cross BC. And in fact, I use a different method for cross product than the method that's in the textbook that you probably learned. So I'm not going to bother going through my method because I don't want to confuse you. I'm just going to go straight to the answer, this cross product. And if you want to practice cross product, then you can work through finding it on your own. So once I get the cross product here, it's -21, -26, 1. So that is my vector E, And recall that that is perpendicular to the plane because the cross product is always perpendicular to both vectors that you cross. And so now I'm going to take vector E and I'm going to, actually I don't even need to write this again. If I take vector E and dot it with vector CD, which is also in the plane, it should be equal to 0. So that looks like negative 21, negative 26, 1 dot 0k3, and that's going to give me negative 21 times 0, which is 0, negative 26k plus 3 equals 0. And if I isolate k in this equation, then I get k equals 3 over 26. So what that's telling me is that if k is 3 over 26, then all of these points, A to D, lie in the same plane and therefore define a plane, right? You could check it by putting 3 over 26 in for k in vector D, and you could find the equation of the plane using A, B, and C, for example, because we only need 3 non-collinear points. And then you could check if D is actually a point in that plane, if you wanted to do all the extra work to do so, or if you had to do it, if you were asked to do it, right? So that is it for that one. This one is not difficult once you know what to do, but requires some clear logical thinking to figure out what the steps should be to get to the answer. So definitely work on that one if you are going to be doing math next year, because that kind of logic will help you out a lot. All right, hasta la vista for now.